Hey everyone, welcome to my channel. This is Sandip and you're watching Packer Crash Course. In this crash course, we'll be learning about what is Packer, what Packer supports, a bit more deep dive into Packer's supported platforms. Then we'll learn about how to install and set up Packer in your machine, and then Packer's core components. And of course, there is a demo, a full hands-on demo that you can follow, and you can make Packer work for you. Okay, so let's get started. Now let's learn what exactly is Packer. So Packer is an open source tool developed by HashiCorp that automates the process of building machine and container images for multiple platforms from a single source configuration. And it helped to create consistent, reliable and identical images for various environments, which is essential in the world of DevOps and infrastructure as code. So, as a summary, we can say Packer enable users to create portable, reproducible, and version control images that can be easily deployed across different environments, improving the overall efficiency and reliability of infrastructure management. Now, let's learn about what Packer supports. So Packer supports mainly three kind of thing. Okay, first is platform and builders, second is provisioners, and third is the post processors. So what are the platform and builders it support? It supports AWS, GCP, and Azure cloud. It also support VirtualBox, VMware, and Docker, which actually create for machine image creation. Okay, so these are the platform and builders that Packer supports. Then provisioners. Now, what are the provisioners? We'll be learning more in upcoming slides, but just as an overview, provisioner are after your machine image basics is done. Okay, you might want to install say other software packages, you may uninstall some software package, or maybe you want to configure the instance, like pre-configure the instance. All those stuff actually we do with the help of provisioners. So what are the provisioner that Packer supports? Packer supports Shell, Ansible, Puppet, Chef. Okay, these are the most popular one, and of course there are other things that Packer support as a provisioner. Then post processor. So post processor are after your build is done, after your image is done. You might want to optimize it. You want to send that image to some other place, or could be anything. Okay, whatever requirement you have after immediately the image creation is done, that you do with the help of this post processors. Okay, now let's a bit deep dive into Packer supported platforms. First is AWS or Amazon Web Services. There it has support for Amazon AMI and support for the ECR. Then for the GCP or Google Cloud platform, we have support for the GCE Google Cloud Images. Then for Azure, we have support for Azure Resource Manager, Azure Managed Disk Images. For other virtualization platform, we have support for say Oracle VirtualBox, OVF, then we have our VDI format, then we have support for VMware, which is VMX and VMDK format. Then you have a containers, of course, Docker is supported fully. Then for other cloud platform, we have support for the DigitalOcean Snapshot, OpenStack images, CloudStack templates, and Alibaba Clouds images. Okay, and for bare metal, we have support for LXC, that is Linux containers. We have support for LXD, which is again Linux containers variation. Then Promox, which is Promox V templates, and Raspberry Pi images you can also build with the help of Packer. So see, so many things Packer supports, right? Now it's time to install and set up Packer in our machines. But before installation, let's see the system requirements. Okay, just minor system requirements. Operating system, it supports Windows, Mac, and any Linux variant. To be honest, majority it has support. Then hardware, any hardware is fine. Okay, just basic CPU and RAM requirements. That is just kind of common for all hardware these days. Then software dependencies. Okay, that is important. So Packer is standalone binary and doesn't have any external software dependencies. However, okay, some builders or provisioner might require additional software or utilities installed on the system. For example, VirtualBox or VMware for building virtual machine images. For example, Docker for building Docker images. Ansible, Puppet, or Chef for the for provisioner if you want to use them as a provisioner for your image creation. Okay, and then network. Of course, you need a very stable network because you'll be downloading, uploading a lot of stuff, right? So stable internet connection necessary to download Packer and access cloud-based utilities such as AWS, GCP, or Azure. Okay, so these are the things is kind of a system requirement you should already have. Now let's install Packer. Okay, and Packer installation actually one of the easiest thing I would say. So first let's go to this official this website. Okay, once you click on that link, it will come to this site. Okay, and here you have support for, you can see Mac OS, Windows, Linux, FreeBSD, NetBSD, OpenBSD, Solaris, a lot of that will support, right? So basically for for me it's Mac OS. I have to just run this particular command, which is brew tab HashiCorp then tab brew install HashiCorp tab packer. Okay, for Linux you have to install, like, run this one. For Linux, of course, there is variant for Ubuntu, for CentOS, Fedora, Amazon Linux, Homebrew. It's had the variety of support, right? Anyway, for me it's Mac OS, so I'll just copy this 2 lines and I will go to the CLI. Just come here and run it. Because I already have installed, so I don't think it will take much of time. I'll just say, okay, Packers maybe already installed. It'll show the message. For you, if you're using a say a Mac OS, then it will show that we're installing the Packer. Okay, so it's already installed, so now it's not installing. Now to make sure that you have Packer installed, you have to just Packer, then that's just version. Okay, and it'll show your Packer version. Okay, just to be sure that, okay, your Packer is properly installed. You'll see that. Okay, so this is the Packer installation. Now, before getting our hands dirty with Packer, let's learn about few basics, which is kind of necessary in order to work with Packer. Okay, just basic things. First is that Packer component. So we'll be learning about Packer components, which is very first is templates, because it's the templates that we'll be working with the Packer. Okay, so what are the templates? Templates are the core component of Packer that serves as a starting point for creating machine and container images. Now, they define the desired configuration. We usually define the desired configuration and setting for the image to build, including the builders, provisioner, and post processor. If you don't know all this, hang on, you will learn about all this in few minutes. Now, a Packer template is basically a JSON or HCL, which is HashiCorp configuration language file that contains the following. This is main section, then variable, builders, provisioner, and post processor. Again, if you don't know all this, don't worry. You're going to learn in few next slides. Now, if you ask me, it's better to write on JSON or HCL. I will highly suggest write in HCL. Okay, but if you think about automating even this image build process, then I will say maybe it's easier to generate JSON data, and from there you want to automate. Fine. So if you are just provisioning by manually, then I will say use the HCL or HashiCorp that configuration language. If you're building this entire Packer automation build using automation, that the Packer template also kind of coming from database and all this stuff, then I will say use the JSON format. Okay. Now, in normal cases, it's usually the HCL only. Okay. Now, let's learn about the very first thing, which is variables. Okay. So, what exactly is a variable? So, a variable in Packer templates allow you to parameterize your configurations, making them more flexible and reusable. Okay, and you can define variables in template and use them throughout your configuration files. In HCL, variables are defined in a variable block, and their value can be referenced using the var keyword. For example, you can see here, right? Here we are defining variable. So variable AWS access key, variable AWS secret key, or variable that is a region variable. You can give additional attributes like type, is it a string, number, or boolean. You can add description. If it's sensitive, you can mention like sensitive true, then it will be sensitive, it will be treated as a sensitive way. Or if you want to add a default value in the variable, you can use this particular attribute called default and assign the value there. So this is the different ways you can define the variable. But now if you don't supply a default value, how you can pass you the values? So for that you have two popular way. First one is you can supply the parameter. For example, to start the build, you have to actually use Packer build var, then Packer build, then if you have additional variables value you want to supply, so Packer build then dash var and after that you just have to mention the variable name and equal to whatever the value they have. So for example, Packer build var dash var, then AWS access key is equal to your access key, and AWS secret key is equal to your AWS secret key. Okay, and then after giving space, you just have to mention what is the template that you want to build or to process. That is template.pkrsl. It could be any Packer file, a template file that you want to build. Okay. Now you can pass all these values via file also. Okay. For that you have to use a flag called var dash file. For example, you have a file with all the variable values like say AWS access key is equals to whatever value you have, regions equals to whatever value you have, and that file name is say for example variables.pkvers.hcl. okay, and there you have a value like this, see, AWS access key regions, okay, that you have to pass. So for that you have to run Packer build dash var file then skip space, then mention this particular variable file, and then give the that template file that you want to process. Okay, so these are the ways you can use the variables in Packer template. Okay, now let's learn about the variable types. First, user variable. So just now the example I've shown you, those are actually the user variables where you define the variables and use them. So user variables are defined by the user, like us developers, in the Packer template, can be used to parameterize and as in the configurations. Then user variables are defined using the variable block, using that variable keyword. Okay, in HCL, and their values can be referenced by using var keyword, and you can assign the default values to the user variables, like I show you how you can define. And the support or the support types are string, number, bool. Okay, also there are complex type such as list type or set type or map type, right, or object type. Okay, just like if you have ever used the Terraform, those things that's supported in Terraform, exactly the types are here because both are written in the HashiCorp language, right? Then there is second one is the environment variable. So suppose environment or say your system wide variables. Okay, so what are the environment variables? So environment variables are the values set outside of the Packer template, typically at operating system level or where you're running the Packer. So when host in OS you're running your Packer, Packer say application, there in the system that variable is available. Okay, so Packer can access the environment variable using the env function. Okay, so in your OS, if you have defined a variable in OS level, okay, using it's available system wide, like in Packer, if I want to access that environment variable value, I have to use that env function, and this allow us to pass the sensitive information such as API keys or credential without hard coding them in the template. For example, in this example, if you see here that I'm defining a source, which is, and we'll come to what exactly source and all that. Think about for now to build the image. Okay, so that we have source Amazon EBS example here. So source Amazon EBS example where I'm supplying access key and secret key. Okay, these two things which are super secret, that as a env. So instead of defining the user defined variable using this variable, that part, we are just using env function to pass on these two AWS access key and access secret key directly from environment variable or environment or from the OS. Okay, that we can do. This is the two ways. Another way is actually which is not purely variable also, but kind of variable you use, or you can say the dynamic variable that you use. Okay, that is local. So in Packer's HCL templates, the local block is used to define the local values that can be used throughout the configuration file, and these local values are like variables only but are computed within the configuration. It is not like you are supplying a dynamic variable as such. You can make the dynamic calculation with this you can make dynamic calculation and store dynamic values directly in these local variables. Okay, and this is not directly exposed as an input variable or output. It's kind of locals are local variables, temporary variables. If you want store some values, dynamic values, for that we use these local variables. Okay, and they're useful for simplifying the complex expressions and or for storing intermediate values, which is the computed values to be used in multiple places within the same template. Okay, for those reasons we use the locals. For example, you can see we can define this timestamp. For the regex replace that timestamp if you want to store, and we use timestamp to generate unique images. Okay, that I'll show you within a few minutes. Then region, let's say any intermediate temporary variables. If you want, you can use the local to define all these variables, and then you have to use local dot that variable name. That's how you can use that variable in other places. Okay, and I will show you within a few minutes anyway. Now, what exactly is the builders? So builders are the core components of Packer that create machine images for various platforms, and each builder is responsible for generating a machine image with a specific infrastructure provider or environment in mind. Now, Packer supports a wide range of builders, enabling you to create images for different cloud providers and virtualization platforms or container systems. And below what the example, you can see the examples here. For AWS, there is Amazon EBS, Amazon Elastic Cellgate, there is Amazon EBS Volume, and there is Amazon Instance. For GCP, we have compute engines images. For Azure, we have Azure Resource Manager images. For DigitalOcean, we have snapshot for DigitalOcean droplets. And there is other builders, for example, IX, LXD, QNU, Scaleways, and vGrand. We have for virtualization platform, we have VirtualBox ISO, we have VirtualBox OVF, we have virtual VMware ISO, and lot other things. So this all these combines help us to build unique images for different platforms. So what exactly is source? So in Packer HCL template, the source block is used to define the configuration for a specific builder, right? And a builder is a component in Packer that generate machine image for specific platform, such as AWS GCP. Just we saw now, right? Right. So, but how it looks like? Okay, it looks like this. Okay. So source Amazon EBS, and you can see this example here. Then for Google Compute, you see this example like here. For DigitalOcean, the example here, DigitalOcean. For Docker, you can see examples. So all these examples you can see are the sources. Now let me show you in a more practical way in the codes how a source look like. Suppose I'm generating a AMI, okay, AWS AMI. For that you can see source, then Amazon EBS, then demo, which is the name of the source. You can use any name to be honest. Then now if you already have AWS secret key and all this configured as a AWS profile, or maybe you have already CLI configured, everything is there. Otherwise you can define the variable like this variable AWS access key, variable AWS secret key, and you can pass on like while discussing the variable section. I show how you can pass using var keyword while running the build. You can pass on these variables, so you can pass like that as well. Now after that, you mentioned the source AMI. Suppose to make a new AMI, you need at least one source. Okay, if you are not sure about this source AMI, you can supply the filters as well. Then you have to show the instance type, then you have to show the username, which is the default username to connect with a particular instance, then the AMI name. It has to be actually a unique name. If you don't have a unique name, it will throw errors. Okay, so this is the source block where you define all the configuration that is required to make that AMI. Okay, now that you have learned about the source block, let's learn about the build block. Okay, so what is build? So a build block in Packer template is used to define the build process, okay, including specify the resource, the sources, which is like if you want to build an image, what should be the source of it? Either could be EBS, it could be like from GCP. So from where the source is, that you define in the build itself, okay, to use. And any provisioning step, suppose you want any additional provisioning step, okay, that also you have to mention on this build phase only. And this build allow you to set up multiple sources as well as multiple provisioner to control the order in which this can be executed. You can define the entire build flow in this build block. For example, you can see here I'm using suppose I want to generate AWS AMI where I'm supplying source.amazonebs.example, just say sample source here. Then I want to set up in that instance Nginx, for example. So I have to run sleep so that the instance can be ready for the first time. Then we are updating all the packages using sudo apt-get update. Then we are like installing all the updates or upgrading also. So sudo apt-get upgrade -y so that it will not ask for any manual intervention. That's what's applying the y. Then sudo apt install -y nginx, and this will install nginx automatically. Okay, now we can of course use multiple sources. You can see the example here. You can use source.amazonebs example. We can use sources.googlecompute.example. So multiple sources also we can utilize. And then in the shell, so you can see the benefit here in this example that the build block specifying two sources, right? Amazon EBS builder and Google Compute image builder. Now and this two shell provisioner. So we can use a single build block to build multiple type of or multi-cloud images, okay, and we can run exact same commands, which is installing ultimately this Nginx. So you can do all that stuff if you use the Packer. Very interesting, isn't it? So this build block is actually critical part of the Packer template, as it orchestrates the build process by defining which sources to use and what provisioners to apply. Now, what are this provisioner I'm talking about? Let's learn about the provisioner now. So what exactly is a provisioner? A provisioner in Packer are used to install and configure the software on the machine image during the build process, okay? And they allow you to customize the image by executing different scripts, copying files, or maybe running configuration management tools like any could be like say Ansible, could be SaltStack, could be Vagrant, could be any tool. And Packers support a variety of provisioners, enabling you to choose the best tool for your specific requirements. So, what are these provisioner? I'll start with shell. So, shell is simply represent the shell scripting. So, you can run different shell scripts while building the image. For example, you want to install Nginx, so you can see this refer to this particular shell, which is provisioner shell. Then inline you are specifying sleep 30, so wait for 30 seconds. Then sudo avd update, like update and upgrade. Then sudo avd install Nginx. So using this this command, we are installing Nginx. For example, if you want to copy some files, okay, see this one, provisioner file. So file provisioner is used to copy files and directories from your local machine to the target machine. And you can see the syntax here, which is provisioner, then you have to mention file, and in the block you have to like specify what is the source of the files and what is the destination of the files. Source and destination you have to mention. Suppose you want to use Ansible. Now Ansible, you already know, it's a very popular configuration management tool. So this provisioner allows you to execute Ansible playbook on the target machine. So provisioner Ansible, then playbook file. You have to give the path of the playbook file that you want to execute in this particular build process. Okay. Then chef. So provisioner allow you to run chef cookbooks on the target machine. Okay. Either in a client server mode or in a solo mode. It's up to you. Now this is the syntax. So provisioner chef solo, then say book paths equal to cookbooks, and run list equal to whatever recipes you want to run. Then for Puppet, this provisioner allow you to apply Puppet manifest to the target machine. For this, you want to use provisioner, then the name is Puppet masterless. There you have to supply the manifest file. So manifest file is equal to the manifest file that you have. Then salt. This provisioner allow you to apply salt state on the target machine. And for this, you have the syntax like provisioner, then salt masterless. Then in this inside the code block, you have to specify local state tree is equal to salt state that you want to apply. So these are different provisioner you have, using which you can install different software, you can run different commands, you can do a lot of stuff. Creativity is the way, and say imagination is a limit how you can do with this kind of provisioners. Now that we have learned about this provisioner, let's learn about the post processor, which is after your build is done. So what are the post processors? Post processors in Packers are used to modify or process the artifact that is generated by the build after it completes. They allow you to perform additional tasks such as compressing, uploading, or customize the output artifacts. Just like the different provisioner Packer support, it support multiple variety of post processor as well, enabling you to choose the best tool for your specific requirements. For example, we can use artifies here. So this post processor allow you to arbitrarily add files as an artifact, which can be useful when Packer, which can be useful when using Packer with external script or tools. And you can see the syntax here. So post processor artifies, then file is equal to the output file. Okay. Then we have shell local. So just like provisioner shell, it execute on that remote machine while making the builds. Here this shell local actually run on your host machine. So this post processor allow you to execute shell script or commands on your local machine after the build completes. Okay. So post processor, then the syntax is post processor, then shell local, and you have to inside that code block you have to mention inline is equal to any command that you want to execute. Then you have the manifest. You can just generate after your build is done. So this post processor generate a JSON or YML file that contain the metadata about the build artifacts. This can be helpful for tracking the artifacts or integration with your own tool, on other tools. Okay, you can use all that. And for that, syntax is this post processor, then manifest is a name, and in the code block you can mention the output path in the manifest file, and script path will be true. Just as there are a lot of attributes you can apply there. Then there is Docker import. So this post processor is used to import a Docker image into the Docker daemon after the build completes, which is post processor. Then the word name is Docker import, and then in the code block you have to mention repository and then tags that you want to specify. Now there is a Docker push. So this post processor pushes a Docker image to Docker registry after the build completes. So and the syntax for this post processor, then Docker push. Inside that you have to specify all the requirements. So what is the login, password, and username and password. And then we have the Vagrant. So using this one, the post processor create, I mean using vgrant post processor, you can create vgrant box from the build artifacts, and this is useful if you want to use the created machine image with vgrant. And this, like the syntax for this, post processor, then vgrant, and then output is equal to output path that you want to specify. Okay, these are different post processor. Now we have actually learned all the basics. It's time to actually get our hands dirty with the Packer templates. Let's start with that. Now let's run this particular Packer file and see how it creates the image. Okay, so very first thing, first we will actually don't need this too, okay, because I in my local I have already configured the AWS CLI, so I don't need to be need to use these variables. Okay, then I need to comment these two lines also. Okay, now I already have everything configured. Source AMI, how to find? You can just go to AWS console. Okay, let me just quickly show you, and there you will find, say, just click on this launch instance, and there just below you'll find this ID. Okay, whatever region, so it will change on different regions. So whatever region is selected, for then you will find this default. You can select, say I want to use Ubuntu. Okay, for that image ID is this. Okay, AMI, and at the end there is B003. So let's verify in my code what I have here. So yeah, this one actually what I'm using. Okay, so there is one source AMI I'm specifying, and then I'm using instance type as T2 micro. I can use any type of instance, to be honest. For example, I want I can use, say, T3 then large, for example. Okay, so T3 large, and I can utilize that. So any instance type that you want to use to build this image, you can use that. Okay, so temporarily, you know what it will do, it will temporarily create the instance with this instance type, and it will generate the AMI from that instance. Let me show you how it's get done, then we'll make a better idea out of it. You see, the next one is that SSH username. Now this Packer will automatically connect with the that instance that is temporarily generated to build this image, and it will, of course, it will automatically generate the temporary keys as well to connect, and all. It will handle every single thing. You don't have to worry about that. Okay, now the AMI name will be this, so Packer demo AMI. This is dynamic because again you cannot have the same name AMI. Okay, otherwise it will throw error. The build, we are just using source Amazon EBS demo, which is specifically means this is the source, then dot, then this is the Amazon EBS, which is ultimately this one, Amazon EBS, then dot demo. Okay, dot demo is the name that you are mentioning. So source dot Amazon EBS dot demo. This is how you should mentally map this. Okay, and then in the provisioner cell, we're just installing Nginx. That's it. And as a post processor, we're just generating the manifest file. Now let me run the relevant commands. First, we'll actually init it. So let's go inside this particular folder, which is Packer cache course, and I will share the repo with you guys so you can refer from there. Okay, now there, first thing we'll run Packer, then init, then the file name. So main Packer, main.packer.hcl. Okay, so let's run it, and okay, no issues. Then let's validate the this configuration file or template file. Could be some issues, right? So run Packer, then validate, then main.packer, and see that configuration also now valid, so no issues. Now is the main part. We have to run Packer build, then main.packer.html, and we'll start the build process. See, first is creating any provided VPC. We don't using any. Then it is defining the name, so Packer AMI, then dynamically generate timestamp. Then it's creating the temporary key pair. If you come to the AWS console, you will see it will quickly generate a temporary instance. See, it's generating a temporary instance in the pending states. It will run all this command that is defined here. Okay, this command as a provisioner cell. It will run all this command, and then it will simply generate the image. So let's come to the CLI and see what happening there. Okay, so here it's that launching the AWS instance, that is the ID here. Okay, now you see it's connected with the SSH with the instance. You see it's connected with the servers automatically. This Packer automatically connects the servers and running all these commands. Okay, one by one it will update the packages, then it will install the Nginx, and after it's done, it will start creating the AMI automatically. Okay, that's the magic there. You don't have to do anything manually, and it's a lot of time saving. Now you can see all the execution of the script is done. So provisioning is done. It's creating the AMI. So let's wait for the AMI to become ready, and then we can check in the go to the AMI console and see all the newly generated AMI. You can check there. Okay, just wait for that. So finally, the AMI is automatically created, or EC2 AMI is generated using Packer. And it took me around 5 minutes 1 second, which is, you can see, wait completed after 5 minutes 1 second. Then build finish and all that happened. So this is the ID of the build. You can see here, this one, that is AMI, this one, AMI, that ID. Let's go to the AWS console and verify it's created properly or not. So let's go to the console. And let's come to the EC2 AMIs and let's search for the AMI. You can see here anyway. So yeah, see Packer demo AMI, which is automatically created by Packer. And one interesting point, after your image is generated, Packer will automatically terminate your instance. So you can see this instance is now actually terminated. If you see here, it's actually getting terminated. So it will not be charging anymore. You will get only bill for the few minutes or seconds that is used to generate the image. That's it. You will not get too much of charges. Okay. And that is it. It will automatically generate the AMIs. You can check the AMIs here, which is newly generated and all that. You're good. We have successfully learned Packer. We have successfully executed Packer and created AMI automatically using the Packer templates. So that's it. Thank you for staying this long and joining me on this Packer crash course learning journey. I hope that you have found it very informative and helpful. Maybe you will be using your day-to-day basis. That is my hope, at least. And I encourage you to practice. There is no alternative to practice. The more you practice, then you will learn a lot of other things. Okay. And if you enjoyed this session, by the way, please consider subscribing to this channel, share this video, and of course give a like. If it reach a lot of likes, maybe just target for 1,000 likes, then I will make a session on advanced Packer, that is multi-cloud Packer implementation, that I will do. Actually, the script is also ready. I have a lot of script ideas in my mind, a lot of real life use cases. But yeah, if there is a lot of interest, then only I will consider making that. Okay. So yes, thank you for staying this long. Hope to see you again in my next video. Bye bye.